Hi students, welcome to a new video series. We are in lesson plan 7 and we are going to learn about convolution sum. Now, convolution sum is a dual of convolution integral which we have already discussed in the previous video series. Whenever we talk about continuous time functions or continuous time signals, we will talk about integrals, and whenever we talk about discrete time functions or discrete time signals, we will talk about summation. Here also the same thing. In the previous video series, we have discussed about convolution integral because we were trying to analyze the continuous time signals and continuous time systems. In this video series, we are trying to analyze discrete time signals and discrete time systems. As I explained in the introduction part of the previous video series, when you have to solve a big engineering problem, we will divide them into small chunks so that the discussion will be easier. When I have to take a bigger video of a concept, I will divide them into small chunks for that it will be easy for me to edit and upload, and it is easy for you to watch and learn. In the same way, when we try to build our house, we will not see that as a big problem of building the house. Instead, we will divide them into different floors first, then we will divide them into rooms, then we will divide them into rooms, and from there we will divide them into walls, then we will divide them into bricks, etc. So the smallest element of a building is bricks. In the same way, we can represent any complicated signals using impulses. That is the important idea we are trying to convey in the previous video series and this video series. Any complicated or complex signals we can represent in terms of impulses. So we know that impulses are the very simple signal which occur only at a zeroth time index, and before that time and after that time the signal will be zero. It will occur only at zeroth time index. So using this simple impulse signal, we can approximate any complicated signal. Now what is the advantage of that? If you know the response of a system to this particular impulse signal, then because of linearity and time invariance, we can approximate the output using the impulse responses. So you have an impulse, you have a system, you have an impulse response. So now we have approximated our complicated signal using impulses, so that we can also model or approximate the output of the system to this complicated signal using the impulse responses. That is the key idea, and this idea leads to a wonderful concept known as convolution, and there are some properties for this convolution, and this is known as convolution sum. And we will also try to see how can we solve this problem of convolution graphically and mathematically. So that is the main concentration of this particular video series. How can we approach the bigger problem of discrete time signal processing, the signals itself and the system, using small impulses and their responses and the summation of all these impulse responses. After successfully completing this video series, you will be able to analyze the use of discrete time impulse and impulse response in predicting the output of a system and characterizing the system itself. In the process, we will analyze how can we approximate an arbitrary signal using impulses, how can we predict the output of any system if we know the impulse response of that system, and finally, we will try to solve the problem of convolution using graphical method and mathematical method. Now, let us go into the videos and try to understand what are the concepts in convolution sum.